So our class is preponed today, right? नहीं पहले ही होता है ना हर बार बाद में होता है ना सेकंड लेक्चर Where did we stop in the last class? कल मैं बहुत खुश था आज देखो अटेंडेंस कम हो गई है ना कितने लोग एब्सेंट हैं आज one on this side two on this side right only one absent Ujjwal sound. So I think we have completed reflection of sound, echo.
Yes.
And we also did applications of echo. All uses we did. Dog, bat, dolphin. You were doing numericals? Echo in medical period, yeah. So depth. Echo's depth sounding, that is also done. Ranging is done. Okay. So shall we take up numerical or let me complete the topics because there are so many reduced topics. We'll finish that and then we'll take up numerical. Right. So we have two more topics in this chapter. So our topic today is natural frequency. Right? Then free vibrations. Damped vibrations. Okay. And then we have force vibration. Okay. So just understand the concept. So what is natural frequency? You are a 10th ICSE student?
Yes.
New admission? You are what?
He is not enrolled in physics.
Achha, this is a physics batch.
Geography is next.
आज थोड़ा टाइम टेबल चेंज हो गया इसके लिए. Okay. क्या हो गया? It happens sometimes. You know, sometimes I've reached different branch college. तो हो जाता है. So what is natural frequency? I explained that yesterday. नहीं ना? नहीं explain किया था. Did I not explain natural frequency yesterday? No. Are you okay, all of you? इतना confidently no बोल रहे हो? रात भर सोए थे कि नहीं सब लोग पहले बोलो? Natural frequency is the frequency with which the object vibrates. Natural frequency. Okay, so every sound has a unique frequency, and every object has got a unique natural frequency. Understood? इसलिए उसका साउंड यूनिक आता है हर ऑब्जेक्ट का. ठीक है? माउस ये सब किया था कि नहीं कल मैंने? वही तो समझा रहा था. That's natural. अच्छा, इसलिए लिखाया नहीं मतलब किया नहीं. अरे ऐसा थोड़ी. ठीक है, चलो I'll keep this in mind. So any object capable of vibrating okay, when disturbed from its mean position, okay, oscillates with its natural frequency. Right? It is unique for a given object. ठीक है? So every object has got its natural frequency. That is why they sound different. Glass, अलग दिख रहा है. Can you see the difference? Handle, you will see the difference. Okay. So what is mean position? Let's say this is a pendulum, right? So if I move it, so it is vibrating across its mean position. So this is its natural frequency, right? Now this natural frequency, जो भी frequency थी, if I change the amplitude, then also it will vibrate with the same frequency. Okay, its frequency will change only when its length is changing, right? Because what is frequency of a pendulum? What is time period of a pendulum?
Time taken.
Is it 2 pi root L by G? 2 pi or 4 pi? What is time period of a pendulum?
2 pi.
So it is 2 pi root L by G, right? So what is the frequency? 1 by 2 pi root G by L. So frequency only depends on the length. It does not depend on amplitude, correct? So if I vibrate it with a bigger amplitude or with a smaller amplitude, its frequency is same. ठीक है? ये तो कहानी होगी natural frequency, right? Now let us understand free vibration. What is free vibration? So if you look at the wave or graph of the free vibration, in terms of this graph, there's displacement from the mean position. ठीक है? तो free vibration के केस में क्या होगा? Once it is set into vibration, it will vibrate forever. If the vibrations are free, it will vibrate forever. ऐसा होता है क्या? Will it vibrate forever? अच्छा, wait करके देखते हैं. Why?
It loses energy because of air resistance.
Yes, because it is vibrating in air, and air क्या करेगा उसको oppose करेगा. इधर जाएगा तो भी oppose करेगा, और इधर जाएगा तो इधर से oppose करेगा. So during each oscillation, it is losing some energy. जब मैंने इसको ऐसे vibrate किया, तो I gave some energy, right? So, but air is continuously dissipating its energy. So during every oscillation, its amplitude is reduced. Okay? So these are not free vibrations, right? So in real life, free vibrations are not possible. It is just a concept. Okay? It is possible in vacuum. But that is not a normal situation, it's a laboratory situation, right? So in real life, free vibrations do not exist. But imagine if there are free vibrations, its displacement time graph would look like this. Its displacement time graph would look like this. Means its amplitude is not reducing. Okay, so it will have plus A and minus A. So with time, the amplitude should not reduce. Okay, so for free vibrations, so this is what displacement. Displacement versus time graph. Okay, for free vibration, what does it show? It shows no decrease in amplitude of vibration with time. Okay, this is point number one. So free vibrations are practically not possible. Right? Due to loss of energy of oscillating particle or vibrating particle object due to surrounding air resistance. Okay, so whenever it is oscillating, air is trying to resist the oscillation, so it will lose energy. So free vibrations are possible only in vacuum. But in real life, we won't get vacuum. We will always have air in the surrounding of any vibration. So what will we get in real life? After every cycle or during the oscillation also, the amplitude will continuously reduce. Okay? So in real life, the vibrations will be of this type. हमने क्या देखा था? Displacement continuously कम होते हैं, ठीक है? So the amplitude will be something like this. Okay. So this is all this. The amplitude continuously NE, just check this one, continuously reduces with time in this case. Due to resistance by surrounding it. Resistance or friction, you can also say, or friction by surrounding it. So this is surrounding error. Okay, so here we have assumed that there is no surrounding error. In vacuum only you will get this, right? But in real life, you will actually get this kind of vibrations. Okay. So what are the examples? Like oscillations of a pendulum. Oscillating pendulum. Will stop after some time. Right? It will stop after some time. Second, suppose the branch of the tree, okay, you pull and leave it, तो थोड़ी देर ऐसा वाइब्रेट होके रुक जाए. You pluck some fruit, तो फ्रूट टूटा तो ब्रांच नीचे आया, जैसे ही फ्रूट टूटा तो ब्रांच थोड़ी देर वाइब्रेट होके रुक जाए. Now branch of tree when stretched when pulled and left. Will vibrate for a short duration. Okay, short duration. So all such vibrations are called damped vibration. Right? It will stop vibrating after some time. But to be able to work in real life, right, we require sustained vibration. We need vibration like this. तभी अपना काम हो पाएगा, right? तो वो कैसे होगा? Like in automobile, क्या होता है? When the engine is started, engine में क्या होता है? There is a cylinder piston, right? Automobile engine में क्या होता है? Cylinder piston is there, something like this. So you have a cylinder and piston है. And there is a wheel which is fixed in the center. Okay? So when the engine is started, right, there is a petrol and air mixture which is injected in the cylinder, and then there is a spark plug which will give flame inside. So combustion will take place, right? So when the petrol and air mixture burns, so the gas will expand. So when the gas expands, so क्या होगा? This piston will move up. ठीक है? It will go up. So then it will rotate this wheel, let's say in this direction, right? Let's say it goes like this and rotates in this direction. ये कैसा है? ऐसे तो रिवर्स जाएगा, ठीक है? मतलब इसको ऊपर बनाना है. Because we are more used to of understanding clockwise direction. ठीक है ना? सो ये क्या करेगा, इफ इट मूव्स अप इस डायरेक्शन में, राइट डायरेक्शन में, तो ये व्हील को कैसे रोटेट करेगा, ऐसे, राइट। तो यहां तक ये एक्सपैंड हो रहा है, बाद में वंस द व्हील इज सेट इनटू मोशन बाय इनर्शिया ये व्हील पीछे आएगी, ये पीछे आएगा तो ये फिर पीछे आएगा, ठीक है। तो पहले क्या हुआ, एक्सपैंड हुआ गैस, तो ये व्हील आगे गया, फिर व्हील के इनर्शिया से पीछे आया तो कंप्रेस हुआ, लेकिन गैस तो अंदर बर्न हो रही तो फिर से एक्सपैंड होगा, एक्सपेंशन हुआ, फिर इनर्शिया से कंप्रेशन हुआ, एक्सपेंशन कंप्रेशन। तो ये जो पिस्टन है वो कैसा मूव करेगा, धड़ 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 आवाज आती है ना बंदा इंजन स्टार्ट, तो धड़ धड़ इसका ही होता है, सिलेंडर पिस्टन मूव करेगा। तो अब तुमको ये जो जो ऑसिलेटरी मोशन है ये किसमें कन्वर्ट हो गया, रोटेशनल में, ठीक है। अब ये जो घूम रहा है उसको तुमने चेन लगा के, जो पीछे की जो व्हील है मोटरसाइकिल, ठीक है, या कार की, इंजन यहाँ सेंटर में घूम रहा है, वो ट्रांसमिट कर रही है चेन से पीछे, ठीक है। तो गियर जब लगाते हो तो ये तो इंजन अकेले घूमते रहता है न्यूट्रल में, जैसे तुमने गियर डाला वो क्या होता है, उसको आगे अटैच हो जाएगा चेन, चेन में कहते हैं, अब वो रोटेट करता है तो चेन रोटेट हो रहा है तो पीछे इंजन रोटेट होने लगे, ठीक है। अगर तुम्हारी ऐसी, अगर वो ऐसे वाइब्रेट होगा तुम्हारा पिस्टन, तो कितने दूर जाएगी मोटरसाइकिल तुम्हारी, खाली पार्किंग से बाहर रहेगी। तो वैसा चाहिए क्या हमको, हमारा क्या होना चाहिए, ऑटोमोबाइल चलते रहना चाहिए, यानी हमको इसका जो वाइब्रेशन है ना वो मेंटेन करते रहना पड़ेगा, ठीक है। तो वो कैसे मेंटेन होगा, अभी जो ड्यूरिंग वन वाइब्रेशन जो भी एनर्जी लॉस होगी, अगर हम उसको फिर से उतनी एनर्जी सप्लाई करते हैं, व्हाटएवर एनर्जी वाज लॉस्ट, अगर हम उसको फिर से सप्लाई कर दें तो हमारा ये कंटिन्यूअसली वाइब्रेट होता है, समझ आया। सो रियल लाइफ में अगर आपको ऑसिलेशंस चाहिए, हर मशीन में, ऑटोमोबाइल में ये यूज होगा, ऑसिलेटरी मोशन इज कन्वर्टेड इनटू रोटेशनल मोशन, ऑसिलेशन टू रोटेशन, यही होता है ऑल ऑटोमोबाइल्स, ठीक है। So what kind of vibrations are expected? We expect sustained vibration. Most vibrations are needed to cause sustained vibration. Right? तो अब हमको constant amplitude का vibration मिलेगा, ठीक है, फिफ्थ टाइम। सो प्रैक्टिकली ये हमारे लिए यूजफुल है, सस्टेन्ड वाइब्रेशन। वो भी मिलेगा कैसे, पेट्रोल तो हमारा हमेशा बर्न ही होते जा रहा है ना, ऐसा तो नहीं कि एक बार पेट्रोल डाला उस वक्त गया नहीं, वी आर स्पेंडिंग एनर्जी, ओके। तो उसको हम अच्छे से लुब्रिकेट करेंगे, वो सारा कुछ करके वी आर कंटिन्यूअसली बर्निंग पेट्रोल टू गेट सस्टेन्ड वाइब्रेशन, गॉट इट। तो अब रियल लाइफ में अगर मैं तुमको बताऊं, अगर मेरे को यहाँ पे सस्टेन्ड वाइब्रेशन चाहिए तो मुझे क्या करना पड़ेगा, आई हैव टू अप्लाई अ पीरियोडिक फोर्स, कम हो गया फिर इसको धक्का देते हैं, जैसे माँ बच्चे को झूला झुलाती है गार्डन में, एक बार छोड़ के थोड़ी देर क्या क्या करने लगेगा, वहां फिर से धक्का देगी, फिर चुप हो गया, तो धक्का देते रहो पीरियोडिक, ठीक है, पीरियोडिकली धक्का देते रहो, काम करते रहो। सो जैसे यहां से आया, हवा से कम हुआ, क्या क्या किया, फिर धक्का दिया, ऐसा, ठीक है। तो दिस इज अ फोर्स वाइब्रेशन में हम क्या करते हैं, वी अप्लाई अ एक्सटर्नल पीरियोडिक फोर्स, ठीक है। तो अब पीरियोडिक फोर्स की क्या होगी, फ्रीक्वेंसी, वी आर रिपीटिंग द फोर्स, दैट इज द फ्रीक्वेंसी ऑफ द अप्लाइड फोर्स। तो अब ये अपने नेचुरल फ्रीक्वेंसी से नहीं वाइब्रेट करेगा, फोर्स वाइब्रेशन वाइब्रेट्स विद द फ्रीक्वेंसी ऑफ द अप्लाइड फोर्स, समझ आया। ये सारे बॉडीज कैसे ऑसिलेट हो रहे थे, नेचुरल फ्रीक्वेंसी से, ठीक है। लेकिन जब हम फोर्स वाइब्रेशन की बात करते हैं तो द object vibrates with frequency of the periodic force, not with its natural frequency. समझ आ गया? ये बड़ा डिफरेंस है. In case of forced vibration, the oscillating object vibrates with the frequency of the external periodic force. समझ आया? देखो. In case of forced vibration, the object oscillates और वाइब्रेट एक ही बात है. वाइब्रेशन स्लो होता है, ऑसिलेशन फास्ट होता है. ऑसिलेट्स और वाइब्रेट, जैसे जब पेंडुलम ये हो रहा है ना, नहीं, ऑसिलेशन स्लो होता है, वाइब्रेशन फास्ट होता है. ठीक है, दिस इज ऑसिलेशन. वाइब्रेशन क्या हो गया? इसका मूवमेंट. जैसे शेविंग मशीन है, कैसे चलती है नीडल, दैट इज वाइब्रेशन. ओके, या ट्यूनिंग फोक है. ट्यूनिंग फोक कैसे चलता है? देखा है ट्यूनिंग फोक? सो व्हेन यू हिट द ट्यूनिंग फोक इट वाइब्रेट्स. बट पेंडुलम में यू कैन सी, क्लॉक का पेंडुलम दिखता है, दैट इज व्हाट ऑसिलेशन. In case of forced vibration, the object oscillates or vibrates with the frequency of external periodic force. Means to achieve the sustained oscillation, ये concept diagram है. You don't have to draw this in your exam. In your exam तुमको खाली ये draw करना है. तुम्हारी understanding के लिए था कि why we need forced vibration. Forced vibration में हमको energy spend करनी पड़ेगी. Some external agency has to continuously make up for the lost energy. ठीक है, तो हमेशा बॉडी के, वाइब्रेटिंग बॉडी के बाहर से आएगी. ठीक है, लाइक यहाँ पे हमने कुछ अरेंजमेंट किया होगा थर्मोडायनेमिकली, तो देयर कुड बी वेरियस वेज ऑफ सस्टेनिंग द ऑसिलेशन, लाइक मदर maintaining the oscillation, or in this case the combustion process. So in case of force, the object oscillates or vibrates with the frequency of external periodic force. अब देखो, अब इसमें एक स्पेशल केस बनता है. अब ये ऑसिलेटर है, इसका तो एक नेचुरल फ्रीक्वेंसी है. ठीक है, और जो फोर्स है वो एक्सटर्नल फ्रीक्वेंसी लगा रहा है उसके ऊपर, राइट? फोर्स इज अप्लाइंग, being applied periodically, so there is a frequency of force and there is a frequency of vibrator. When the external applied periodic frequency of force matches the natural frequency, that time the vibration takes place with maximum amplitude, and that is called resonance. So when frequency of external periodic force is equal to the natural frequency of the vibrating object, right? The vibrations take place with maximum amplitude. Okay, this is called resonance. ठीक है? This is called resonance. So resonance is a special case of force vibration. Got it? So question. What if the frequency of the applied periodic force is much different from the natural frequency of the object? Then what happens to the amplitude? Huh? Because if the frequency same, जैसे ये यहाँ से आया हमने और दे दिया तो बहुत बड़ा एम्पलीट्यूड मिलता है, लेकिन ये कुछ फ्रीक्वेंसी से हो रहा है और ये मैं कुछ और फ्रीक्वेंसी लगा रहा हूँ, तो क्या होगा? इसकी एम्पलीट्यूड बहुत कम हो जाएगी. Oscillate तो होगा, but it will oscillate with a very small amplitude. Okay, that's the only difference. ठीक है? अब ये लिखाया नहीं है तो ये मत बोलना पढ़ाया नहीं. लिख लो इसको, खुद से लिख लो. Write down. When the applied periodic force frequency is much different from the natural frequency of the vibrating object, then the amplitude of the force vibrations are very small. Of the forced vibrations are very small. Clear? And what will be the frequency? What will be the frequency? Frequency will be of the periodic force. Force vibration में frequency क्या होती है? With the frequency of external periodic force. समझ आ गया? तो force vibration में object always vibrates with the frequency of the applied periodic force. So the difference is only in the amplitude. If the applied frequency matches the natural frequency, the vibration will be of large amplitude. Okay? But if it is much different than the frequency, natural frequency, it will vibrate with the frequency of the force vibration only, but now with a small amplitude. Is that clear? So with this, our time ends at
7:50.
So with this, we have completed natural vibration, damped and forced vibrations. So there are some consequences of forced vibration. So look at this experiment. So this is a sound box. Okay, any wooden box with opening on one side, right? So there is a air inside the wooden box. So these are two identical sound box. What are we calling it? Sound box. You have seen guitar, right? So guitar is a big box, right? So it is a sound box. So when you vibrate the string, The sound produced in the string is very small, but it vibrates the air in the sound box, and that's how the sound becomes amplified. So if you only play the string without the sound box, the sound will be very small. Okay? So since the air inside the sound box start vibrating at the same frequency as the string, the sound amplifies. So now the sound is loud, frequency is same. Okay? So I will talk about loudness, frequency in the next topic. So now let us understand this resonance with the help of sound box and tuning fork experiment. So this is a tuning fork when it is set into vibration, right? Everybody understand what is tuning fork? All of you have seen in your labs? Huh? नहीं. So tuning fork कैसा होता है? एक U shape में ऑब्जेक्ट होता है, U shape, ठीक है? और उसको नीचे एक सपोर्ट है. So it's like U and one stem below. ठीक है? So अगर तुम उसको एक रबर पैड पे हिट करोगे, when you hit it, then both the tongs, these tongs, okay, these tongs, they will start vibrating like this, very fast. And what is the frequency? It is printed on it. So it will have its natural frequency, say 256 hertz. Like in 1 second, it will vibrate 256 times. It's very fast. So when you look at it, it will look spread. It will start looking thicker. Like when the fan is moving, it looks like a sheet, right? But there are only 3 blades, right? So it vibrates so fast that it will start appearing to you thicker. Okay? Can you imagine any vibrating object? How does it feel? Can you see this? What can you see? The finger is like all over the place, right? Like that. So suppose this tuning fork is vibrating with its natural frequency. Now you place it on the sound box. So this frequency will be transmitted into the air in the sound box. Now the air in the sound box will start to vibrate with the same frequency. That frequency of air will be transmitted and it is reaching the other sound box. Okay? So here also the air is now vibrating. Now this air will cause this tuning fork to vibrate. This tuning fork is only kept here. So this will begin to vibrate. Now natural frequency of this tuning fork, these two are identical tuning fork, right? And this air is now causing forced vibration in this tuning fork. Now the frequency of this air is same as this tuning fork. So it is equal to the natural frequency of this tuning fork. So now you see big vibrations in this tuning fork also. So this is a case of resonance and a loud sound is heard. Understood? So if you keep a tuning fork of different frequency, then you will not hear a loud sound. So this confirms resonance. Okay? So here the vibrations is caused in this tuning fork, right? It is forced by the vibrations in air, and this frequency of air is same as the natural frequency of the tuning fork. Then you will hear loud sound. And in the lab, you will see when you conduct experiment, when you hit a tuning fork, a humming sound will be created because any vibrating object will create a sound. So when you bell पे मारते हो टंग करके आवाज आता है, वैसे tuning fork में humming sound will come. ऐसा करके बजाएगा. ठीक है? She finds very funny, and hears all the time. It's okay. Like lab में जाना शुरू हुआ है कि नहीं? और Corona restrictions are still on.
Yes.
In your school it is started laboratory. किसी के स्कूल में start नहीं हुआ अभी तक? Not started? Wow. School cares so much about it. ठीक है. तो एक तो we have learned this demonstration, right? Next is one more is this pendulum wala thing. So there are multiple pendulums. How many pendulums are there? 4, A, B, C, D. ठीक है? All these pendulums are hanged on a rubber shaft. Okay, listen carefully. All these pendulums are hanged on rubber shaft. So this shaft is not metal, it's not rigid, it is flexible. Now when you set oscillation in pendulum A, like A को तुमने ऐसे, ये ऐसे है और pendulum कैसे लटका है इसके अंदर? समझो ये rod है, तो I am oscillating like this, and rod is like this. So because of this vibration, this, since it is made up of rubber, this also will be twisted. Okay? So once the oscillation is set up here, when it goes here, this will be twisted. That twisting will cause twist in the other hanging pendulums. Correct? Now, for a pendulum, the frequency only depends on length. Right? So, if these two pendulums are of same length, then these are identical. This will have identical natural frequency. Correct? So, once the vibrations are set up in A, B is of the same length. So, you will observe that the amplitude of the vibration caused in B is same as A. So, this is due to resonance. But they have different natural frequencies. So, here you will see that these pendulums will vibrate with a low amplitude. So, the question is asked why A and B are oscillating at same amplitude due to resonance. Okay? Because the frequency of A and B matches. So how these vibrations, are these force vibration? Yes. We only cause vibration in A, but these vibrations were transmitted to C, B and D also. So these are externally forced vibration over here. Got it? So the frequency of all the pendulums will be same. Only the amplitude is more between A and B. Is it clear? So this pendulum experiments completely demonstrates resonance experiment. Okay. So now some examples of resonance in real life. It is given over here. Right? Can you see? So resonant vibrations of pendulums. I just explained that. Two pendulums of equal length, right? If they are connected through some shaft, the vibration in one pendulum will be transmitted to the other pendulum and both pendulum will vibrate with equal amplitude. This shows resonance. Second is resonance in machine parts. Machine parts में क्या होता है? Sometimes you will see that when the automobile is running, if there are some loose parts in the machine, right, the sound will suddenly increase. Okay, the sound will become very loud. That time, when you change the speed of the machine, then it comes under control. So by changing the speed of the machine, the natural frequency of the, say, nut, there is a loose nut. Okay, have you observed while going in a car, mobile is kept, so it starts vibrating, right? So it's very annoying, and when you change the speed of the car, that time this vibration will slow down. So when the natural frequency of the vibrating object matches the machine frequency, so the loud sound will be heard. Okay, so that is a resonance phenomenon, right? So that's why they say we keep listening for any unheard sound, like different sound. Okay, that means kuch time to take it to service, not lose it, usko tight karo. Otherwise, if the vehicle is perfect, it will not cause any unnatural sound. The resonance is also alert that something is wrong with your automobile. Is it clear? मतलब कभी होता है ना कि और कैसे समझाएं? This is one example. ठीक है, let's restrict ourselves to the example of your book. Next is resonance in a stress string and sound box of musical instrument. I explained you. What is that? Guitar का string play कर रहे हो. If the string का frequency matches the natural frequency of the air, then loud sound will be heard. Okay? So this is done with lot of experience. That is how the musical instruments are manufactured. So manufacturers have the knowledge, domain knowledge, right? So they make use of resonance over there. Then there is resonance in bridge, resonance in radio and TV receiver, resonance in air column and tuning fork. That I already demonstrated with the help of soundbox experiment, right? The fourth part. The fourth part is this experiment. तो मुंडी हिला रहे हो कुछ है क्या तुम्हारे पास? बुक बुक है ही नहीं, कहाँ से पता चलेगा? ठीक है, anyway, घर जाके पढ़ना और अगर नहीं समझ आया तो नेक्स्ट क्लास में पूछना पड़ेगा। इस पे 1 मार्क का क्वेश्चन कुछ आ सकता है कि अब रेजोनेंस इन ए ब्रिज, क्या है रेजोनेंस इन ए ब्रिज? So when march past, when the soldiers are doing march past, right? They are asked to get dispersed on bridge. Bridge पे march past करने को मना करते हैं, क्योंकि when you do march past, if the frequency of the march past matches the bridge frequency, then the suspended bridge will start oscillating, and it will oscillate so much that it might get broken. That's why on a suspended rope bridge, soldiers do not do march past. They do it on a firm road or hard surface. Got it? So this is why they are asked to break their steps. So when a troop crosses a suspension bridge, the soldiers are asked to break their steps. Okay? The reason is the resonance might break the bridge because it may start vibrating with a large amplitude. दूसरा resonance in radio and TV receiver. अब ये क्या होता है? देखो, when you are tuning your radio, right? Sometimes if the station is not caught properly, the noise is not clear. You hear a lot of noise, right? So at resonance, what happens? Every electronic circuit has its own natural frequency, right? Like if this TV, cable TV में those signals which are coming to you, so that dish antenna catches it, right? So the signals which are received, if those frequencies are matching your TV frequencies, only then the channel will be seen clearly to you. Okay, so at resonance, the signal strength will be maximum. So that's how that channel will be seen clearly. Okay, so that's what is resonance in case of radio and TV receivers. So whether it is a radio channel or a TV channel, okay? So that is, so resonance takes place in various situations. Whether it is mechanical resonance, like in case of sound, it could be electrical resonance. Now that signal is electromagnetic waves. Okay? So it's not that resonance takes place only in case of sound waves. All kind of waves it is possible. Okay? Like I am explaining something. I am explaining something to you, and your brain frequency is not matching my frequency. You will understand maximum when you are tuned to me completely. That's when resonance happens. Now you understand what is resonance? So resonance is the net result. Otherwise, if the frequencies don't match, right, you'll not understand anything. Or if you're not speaking the same language, your understanding efficiency will be very less. Let's say you speak Marathi, I speak Marathi, we both will be able to communicate or exchange each other the information very well. But if you understand Malayali and I speak Hindi only, no resonance possible. Sign language करके थोड़ा बहुत काम चलेगा. समझ आया resonance का मतलब क्या होता है? Resonance means जो मैं दे रहा हूँ या whatever we are expecting, that is reaching the other side with full efficiency. That is resonance. So resonance is applicable in various situations. and it will take place with maximum efficiency when matching happens, matching of frequency happens. Is it clear? So hope it has given you some idea. So this chapter is highly conceptual, and there are so many things given, like, okay, these are not in the syllabus for testing. There is principal frequency, then subsidiary frequency. All those things are not in the syllabus. So whatever I have taught you, only that much is in the syllabus. So we can do some numerical now. Okay, so there are 3 parts in this chapter. In sound, there are 3 parts. One is echo, that is reflection of sound. Second is this natural frequency, free vibration, and the third part is loudness, right? Loudness, pitch, and quality. Quality of sound. These are characteristics of different types of sound. Means how to differentiate between sounds, different types of sound. So we differentiate sounds on the basis of loudness, pitch, and quality. That is the topic of next class, right? Today we did echo and different types of vibrations. So we did 3 force, 3 damp, and force vibration. Right? A special case of force vibration is called resonance. Right? Plus I also explain what is natural frequency. So if you know natural frequency, then only you can understand rest of the vibrations. Clear? Now we'll solve numerical on echo. There are only numericals on echo. Right? So only one formula to be used. What is that formula? V is equal to 2D by T. In this chapter, we have only one formula. V is equal to 2D by T. Rest formulas are only for, like, velocity is equal to frequency into wavelength. This kind of formula. F is equal to 1 by T. Right? Only this. So only one new formula is there. Rest is the relation between velocity and wavelength of the wave. Right? That is. So कोई एक numerical कर लेते हैं. In the next class, we'll do more numericals. This is our second lecture on sound, or second lecture? Okay. Sure. Give me your volume. Let me. You have a volume? I have. So classroom numerical, right? 5 minutes is, I think, the first numerical we can do. Read the first numerical, anybody? Anybody from girls' side? Page number 126. Classroom numerical 1. अरे यार ये कितना हंसती है लड़की. हाँ अच्छा है हंसना, बट हमेशा नहीं है. पढ़ो. तुम लोग ने लिख लिया था ना सर? पढ़ो. स्टार्ट.
The wavelength of waves produced on the surface of water is 20 centimeter. The wave velocity is 24 meter per second. Calculate the number of waves produced in 1 second and the time required to produce one wave.
Okay. So what is asked? Number of waves produced per second in 1 second is nothing but frequency. Correct? One wave is one oscillation basically. So number of oscillations produced in 1 second, right, is nothing but frequency. So this is part 1. Second part, what is asked? The time required for producing one wave, that is time period is asked. Time for one wave is called time period. Okay. So what is frequency? Solution. since V is equal to F lambda, right? So F is equal to V by lambda, right? Now what is V? 24. What is lambda? 20 centimeter, that means 0.2 meter. Okay? So this is 0.2. So how much is this? 240 by 2, which means 120 hertz. So number of waves produced in 1 second will be 120. Therefore, 120 waves are produced per second. This answer. Now what is time period? Time for one wave. Time for one wave is equal to time period, and this is equal to 1 by f. ठीक है? F we just found out. So this is equal to 1 by 120. These many things. So just find out how much would that be. How much is 1 by 120? Calculate. So how can you calculate? So this is equal to multiply by 100 and divide by 100. So this will be 12 into 1000. Right? So multiply and divide by 100. क्या हो जाएगा? 2 6 are 12, 250 is 100. 6 8 are 48. Right? 8.3 हो जाएगा फिर 6 8 are 42, 28, 6 3 are 18. 8.33 into 10 raised to minus 3. Okay? So this is how you have to do smart calculation. Now have I got the correct answer? Yes. This is how it is. So 8.33 into 10 raised to minus 3 second. There answer. Okay. So like that you can try other questions also. I'll see you in the next class.
I think